Let's start first with how did we get hands-on with Hempline. As a student in civil engineering, I got very interested in natural building materials during my studies because what we studied at the university, which was the University of the Technical University of Vienna, was mostly concrete, steel, and timber. Full stop. Nothing else. So I started delving into literature and got into the books of Steve Allen, of Alex Sparrow, and got super excited by Hempline and hempcrete and the possibilities that this material offers. So I was wondering, there must be an ongoing project at the university which I would love to join and have my thesis done on this topic, but unfortunately things did not turn out this way because at our university there was no expertise for that, and the only question that I got was, yeah, great idea, but who's gonna pay for that? So this pushback actually incited some inspiration in me, because I really didn't have a question, like an answer to this question, yeah, who's gonna pay for research which cannot be funded by the university, right? So I started exploring various options, and in 2017 we created a joint project between our university and the Economic University, this is when Hempstatic developed as an idea, as a university project. We started learning about the startup scene back then, participated in a couple of competitions. We were quite a big team, like 5-6 people from the beginning, because most of the people were needing that project to graduate. And after winning these competitions, we split as a team. But this is when I realized I want to continue working on this idea. And back then the idea was not so clear. So we knew we wanted to do something with hempcrete and hempline, but we didn't know exactly what. And we continued just to explore the opportunities of this material, and got into contact with an interior designer who was very inspired by the samples that we built, and asked us if we can solve a specific acoustic problem that they have in a co-working space. And this is how we entered the field of acoustics and soundproofing. When I say we, I mean me and my co-founder Igor, who maybe you have already met. He joined the team also from the very beginning because he has a very complementary experience to what Hempstatic needed to grow. So he brings experience from the construction sector, but also from agricultural trading and design. And I myself have worked at the Technical University at the Institute of Material Technology, Building Physics and Building Ecology, and also did some material science, back then focused on fiber, or using natural fibers for reinforcement in concrete, and next to that developing Hempstatic. So we are the founders team, and we didn't found the company immediately. It took a while to get the guts to really decide to make that step. Okay, we do it. We will do it all in. So let me just walk you very shortly through that journey. We decided to make biodegradable sound insulation because we started to explore the market and noticed there a gap. This market is predominantly or is dominated by plastic insulation, so by polyurethane foams, which means that 99% of the acoustic insulation which is currently used will end up as hazardous waste. And this is what we want to change. In 2019, we did the first project that was back then with this interior designer. We came up with the concept of how such modules could work and installed them in this conference room. And it worked better than we expected. This was also the time before we were a company, so it was a little bit of a hustle of finding a place where to produce it, how to produce it, and then actually delivering the product. But we succeeded. This helped us to jumpstart our journey into hemp-lime acoustics, and in 2020 we got our first funding from the Austrian Development Bank, which helped us to actually bring up the proof of concept, to get the data behind how the material works, and also to continue improving our MVP. So we started focusing more on features that are valued in this space, like the surface, the appearance, and of course the technical performance. We did our first test with that funding. Here what you see is a small test in a window where we tested the sound reduction index of hemp-lime solely. So no other material included. We decided to go for 5 centimeters as an expected standard and got a very interesting sound reduction index of 16 decibel. Now, it was very hard to find a comparison value for this, because as you know, most of the data sheets contain the value of the whole wall profile, which is of course much higher, looks much better. But if you're interested into just knowing how hemp-lime works as a thin plate, it actually delivers quite a result. We did also some sound absorption tests in a reverberation room, which was designed for this. And as you can see here, the surface of our material was still not very sellable, to put it like that. But we got interesting value, and as you can see, there is quite a pitfall in the higher frequency range, which did not look that good. Why? Because usually the foams, the most common used materials in our space, actually have a curve which goes like that. So it goes up high, and usually the higher frequencies are the ones that are easier to absorb. And we started comparing these curves and found out that wood wool, maybe you know it under the name of Heraclite, also a very common material used exactly for sound insulation, has a similar looking curve. And this is to the fact that our materials like Heraclite or wood wool, hemp-lime, they are not isotropic but orthotropic materials. And this is why it's harder to achieve that flat, like that curve as in the foam, as the foam insulation. We then started to work more on the actual surface of the product and try to improve the qualities to make it more attractive for interior design. Interior design is especially hectic because the expectations of the customers are quite high and the surface has to be perfect. We cannot allow ourselves to offer a product that comes with too rustic looking designs, because actually this is not very well received, I mean, in the conventional interior design space. And we decided, okay, let's go and test the real product. So we found out this is the first product that we would want to bring to the market. And we went to test that product after having worked a couple of months on the surface and on the homogeneity of the material. As maybe you can notice a little bit here, we got a better result on the sound absorption, especially in the middle range frequencies, which are extremely important for this use case, for the conference rooms, for spaces where we have human speech. So with these products, we directly implemented them into the project, and in 2021, we were asked to solve 2 issues in common space where multiple children were gathering to celebrate birthdays. So it was getting very loud during these celebrations, and on the one hand, the problem was, of course, the acoustics in the room, because there was a whole window wall on the one side, and then a very high ceiling, 63 centimeters, which was creating these high reverberations. On the other hand, there was a residential building outside, so the people who were living on the first floor were actually having noise transmission issues from this space. And we covered, I think, about 30% of that wall, which was available with our absorbers, and were able to solve both problems with this solution. Since then, we continued to evolve and tested lots of designs and tested what would be the limits of in the production and how can this product be scaled. So all of these prototypes were also implemented into projects, but this is what helped us to narrow down our focus to the current product line that we have. Here you can see one of the projects. This was done also in a conference room, which had a very similar issue. And yes, in 2022, we founded our company, and we entered into the first real production workshop, which is placed in Lower Austria, 30 kilometers away from Vienna, and this is where we operate from currently. This was the year where we continued to evolve our products. It was the year that we got our first investor on board, who actually comes from this competition space, like from the foam sector. And we got further support through the Austrian Development Bank to scale up our operations and bring the minimum viable product to an actual product line. So this is what we did. We really tried to focus on understanding how do all the processes that happen in the mixing and in the drying, curing phase influence the various properties in terms of appearance and in terms of homogeneity in order to achieve better results. And I can show you, these are the 2 main products that we have now in our product line, and this is what we have now set as a standardized product that we can deliver. As you can see, these products contain also a wooden frame in which the hempline panel is embedded. This has, on one hand, design value, but on the other hand, it protects the panel and offers very high stability and very high diversity in how the panel can be installed. So they can be installed both on walls and ceilings. They can be hung up. They can be installed with an air gap or without. And I'll show you a little bit why did we go for this. This is another prototype of ours that we did. We tried to look into how can we make this product also more customizable and made these letters. You can imagine they're like 70-80 centimeters each letter. Exactly, and I think that we will be showing more of that soon. So if we talk about the impact, we did a comparison study with the help of a tool called Climate Impact Forecast, which was developed by the European Institute of Innovation and Technology, and decided to compare our product's impact on with the impact of the poor insulation. This study showed us that there is a potential to save 84% of the carbon-related emissions, whereas about 36.7% can be saved in the extraction phase, about 75% can be saved in the production phase, and the biggest chunk, or there where we actually are able to deliver the highest impact, is at the end of life phase. More than 180% of the emissions can be reduced because we decided from the beginning on to have a recipe which allows the material to become biodegradable at the end of its lifetime. This is a small sample that you can see from which we just took out of the soil. It spent 12 months there, and you can see how the biodegradation process already started to take place. Now, let's get back to the acoustics and soundproofing topic. This summer, we continued to do some acoustic tests to make our values more comparable to the current building standard. And this is setup that you see is from the Acoustic Center Austria, where we did the test. Behind the microphone is our wall system, which we tested. We decided to go for a very conventional wall system, since in Austria this is the most common way to build, and this is the market that we started to focus on from the beginning. So we tested two various thicknesses of the panel at 5 centimeters and 10 centimeters with single layered and double layered gypsum board on both sides. With the first assembly, having a 5 centimeters panel, we were able to achieve sound reduction index of 43 decibels. What you can see here as a difference between the 5 centimeter and the 10 centimeter hempline panel is in this lower frequency range of about 100 to about 250, where we are able to absorb more of the lower frequency range by increasing the thickness. Now, this is usually the frequency range which is hardest to absorb, especially with traditional materials. So hempline is especially interesting due to its ability to absorb frequencies from this range. Usually the higher spectrum from 2000 hertz above is an easy one, and it can be solved even from the more higher than like 10,000 hertz. The reverberation can be reduced with simple measures like curtains, etc. But when we get to the lower frequency range, it becomes really interesting. Let me show you the results also from the double layered boards. There we were able to achieve, with the same thicknesses, 50 and respectively 53 decibel sound reduction. And you can see that the trend is very similar. We did also some testing in an impedance tube, where the sound travels orthogonally to the material. So usually the tests that are done in an impedance tube are deliver worse results than the actual one. So it's a great way to start assessing what kind of performance to expect from your samples. simpler version to start with, because you just need a small sample and not the minimum of 10 square meters, which is required in a reverberation room. Here you can see the comparison of how the material performs when it's directly installed in the wall or installed with an air gap. And the trend shows that the air gap helps in general to improve the absorption and to widen the frequency range in which this happens. This is especially interesting when we talk about installation in the ceilings, since most of the sound, or it's said that about 40% of the sound travels to the ceiling. Yes, this was done with our classic thickness, which is about 4 centimeters. And the graph underneath shows how the material performs at a thickness of 2 centimeters. This is another material that we are currently developing. It's also based on hemp-lime, and I wanted to show you here how the trend actually copies the other performances. So here we have so first to say that this is a result measured directly on the wall, so without an air gap, and we can see that with thinner plates we can absorb only the higher frequencies, whereas if we increase the thickness we are able to absorb frequencies from the lower range. Let's end up with something that we did also an accelerated aging test regarding the color stability under UV influence. I would like to show you also something exciting about hemp-lime is that there is no significant color change in comparison to IHBA. This is the comparison that we made. So here on the left side you can see how the color changes between 0 to 300 hours in hemp-lime. It's almost an insignificant change, whereas the IHBA has a dramatic change in its color. So when we talk about interior and long-lasting product, this is very important. And I would like to end up with a few microscopic images that we did of hemp-lime. This one shows how the hemp sheath, which are these longitudinal fibers, are bonded in this binder matrix, and the gaps that you see, or the empty circles, are the air pores. Here I wanted to show you how good actually the cohesiveness between the binder matrix and the hemp sheaths work. And on the next slide, you'll see the cross-section of the hemp sheath also embedded in a binder matrix. My last photo shows the so-called bioshrinkage, which are these shiny little elements that show the certain crystallizations ongoing after the material has hardened and has undergone the curing process. And it was very interesting to observe under the microscope how the various pores that are available actually have various thicknesses, various diameter sizes, which is especially beneficial when we talk about acoustics and sound absorption. Thank you very much. I would love to invite you to collaborate with us, and thank you for your attention.